In problem number 8, we've got a normal distribution. We don't know the mean. We know the variance is 13. We know the probability that v is less than 15 is equal to 0.75. So on a graph, we could tell that this 15 must be above the mean because 0.75 of the data is to the right or to the left of it. And what we've got to do is find the mean. What we're going to do is we're going to take each of these things and make them equal to a z-score, and then make them equal to each other. So a z-score for this probability of v is less than 15 would be 15 minus mu over square root of 13. And then for the z-score for the 0.75, I can do the inverse normal, put in 0.75. I'm doing a z-score, so the standard deviation will be 1 and the mean will be 0. And I get a z-score of 0.674. Now all I've got to do is multiply both sides by the square root of 13, and then subtract 15, and then divide by -1, and I'm going to get my answer of 12.56 or 12.6. In problem number 9, we've got a variable. It's a normal distribution. We don't know the mean or the variance, but we do know the mean is equal to 4 times the standard deviation. We know the probability that w is less than 83 is equal to 0.95. It's kind of helpful if we go ahead and graph that. You can tell that if 83 has 95% of the data to the left of it, then it must be way over here to the right of the mean. It's got to be a positive z-score. And I can tell that mu is equal to, the mean is equal to 4 times the standard deviation, which I can change that around and find out the standard deviation is equal to the mean divided by 4. So if I go back to do what I was doing before, the z-score equaling the z-score, I have 83 minus the mean all divided by, and we can change this to 1/4 the mean, or we can make it 0.25 the mean, equals z-score for 0.95. We're going to the right, so we just got to put in the 0.95. We get 1.645. And now all we've got to do is get mu by itself. We're going to multiply both sides by 0.25 mu. And then we're going to subtract or add 1 mu to both sides. And then we're going to divide to get the mu by itself. And that'll give us a mean of 58.81310. And then all we've got to do is substitute that back into the formula they gave us. And we find out the standard deviation is 14.703. We round these to 3 significant figures, and then we're good to go. All right, let's take a look at the next one. In problem number 10, we've got a normal distribution. We know the standard deviation is equal to the mean minus 30, which means the mean must be equal to the standard deviation plus 30. We know the probability that x is greater than 12 is equal to 0.90. If I graph that, 12 is going to be over here somewhere because 0.9 of the data has to be to the right of it. And if I were to draw my z-scores, well, it's going to look something like this. So let's start over here on this side. If I set this up as a z-score, this is going to be 12 minus what the mean is. Well, the mean is equal to the standard deviation plus 30. So let's put that in there. And then we're going to divide by the standard deviation. So you notice we only have one variable here. And let's go ahead and clean this up a little bit. This is going to be the standard deviation minus 18 over the standard deviation. And then that's going to equal, and then we do a z-score. Now remember, when we do the calculator, we do inverse normal. Well, if I put in the 0.9 here, it gives me everything. It gives me the value that's going to have everything to the left of it, of 0.9. So what I need is this negative version of that. Ours is negative 1.282. Anyway, now all I got to do is get the standard deviation by itself. I'm going to find out the standard deviation is going to be 63.8, blah, 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 blah. And then all I got to do is go back to this original thing they gave us in the beginning and find out the mean is going to be 30 more than that. And then round to 3 significant figures, and I'm good to go. All right, let's take a look at the next one. All right, number 13, we've got to find the mean, the standard deviation. We're not going to worry about finding this probability. So we've got these two probabilities. The probability W is greater than 4.75. We know that's 0.6858. And we know the probability that W is less than 2.25. That's going to be 0.0489. Now let's sketch the first one. We know that because 68% of the data is above it, that this must be a negative z-score. And what I can do is quickly figure out the percent that should be below it, which would be 1 minus 0.68758. And now all I've got to do is find the inverse of 0.3142, and it's going to be 0.484, negative 0.484. And then I'm going to convert this to an equation, and I'm going to do the same thing to the other one. Now I want to do a quick sketch because I want to make sure what my guy looks like. So here's my normal curve. I know that 0.04 of the data is below it, so that means it's obviously a negative z-score, and I already know what's below it, so when I do the inverse normal, that's going to give that the number to me. So now I'm going to take this 2.25 minus mean over standard deviation. I'm going to do the inverse normal here of 0.0489, and I'm going to find out that the z-score that associates with that is going to be negative 1.656. And then I write my equation. I multiply it by negative 1, put it underneath the other one, and then add them up. And I'm going to get rid of my two means. And I'm going to find out that 2.5 is equal to 1.172 standard deviation. I'm going to divide, and I'm going to find out that I get 2.1331 as my standard deviation. If I substitute that back into one of the original equations, I found out the mean is equal to 5.7824. And then all I got to do is round to 3 so we get figures. All right, let's take a look at the next one. Okay, so in problem number 14, we're going to have to find the mean and the standard deviation. They give us the probability that x is greater than 147 is 0.0136. That means it's not very big. It's over here, this little space. It's above it. But once we do that, we can figure out that 0.9864 must be below it. So then all we do is use the z-score equation and write down 147 minus mu over standard deviation. Do the inverse normal for 0.9864, and we find out that our z-score is 2.209. And then we get that into an equation. We're going to do this one more time. We're going to find the probability that x is less than 59 is equal to 0.0038. That's way over on the other side because very little of it is below it. So that's going to be down here somewhere. We know it's going to be negative. Our inverse normal is going to give us any value that has this much probability to the right. So all I'm going to do now is fill out my equation, fill in the probability 0.0039, get a z-score of negative 2.669, and then multiply standard deviation on both sides, get this equation. I'm going to multiply the whole thing by negative 1. I'm going to stack them up. I'm going to add them together, and the mu's will go away, giving me 88 is equal to 4.876 standard deviation. Then when I divide both sides, I find out the standard deviation is equal to 18.0475. When I substitute that back into the original equation, I find out the mean is 107.132, and then that's all there is for that. Thanks for watching.